Wiggle, 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 wiggle.
This has been a really weird weekend so far. But really well. Everything that could have gone wrong so far has gone wrong. I suppose I should touch wood. Can I find some wood to touch? But we've had the end of our trials and tribulations here. I found some wood to touch. Our next speaker, I was panicking because he got stuck in traffic and all sorts of strange things happened. And I was wondering what to do. But, as always happens, whoever the god or the patron saint of convention running is, he once again came to our rescue, and he is here in the auditorium with us tonight. And hopefully the computer's going to work properly this time, and I think everything's going to be wonderful. So, once again, I can never find Richard Freeman when I'm looking for him. So I'm afraid I'm going to have to pass you over to his evil twin brother, Bryan.
Hi, that Freeman guy, he out just drinking all the time. He don't give a monkeys. Anyways, our next guest is a very important scientist all of the way from Oxford University. He is Professor Bryan Sykes. Now, why is he such an important scientist, you might ask? Yes, well, he is the inventor of the bag. In May of 1974, he invented the bag. Before that, everybody just carried things around on bits of wood. So be grateful he has invented the bag. And he is here tonight to talk about his new invention, which is a mouse scissor radio. Please put it together for the good professor.
Very much, Richard, and your alter ego. And I brought along one of my latest designs, which is very useful for carrying shopping out of supermarkets. You'll love it. And I've even got sponsorship from M&S themselves. Now, can you hear me without the microphone, right?
Yeah.
Yeah? So I'll put that down. And first of all, I want to thank Jonathan and Richard and the Centre for allowing me to talk here tonight. I wasn't going to talk, but it just so happens I wanted to speak to Jonathan for a reason which will become apparent, I hope. And he said, "Oh, we've got an extra slot. Why don't you come down and talk to the meeting?" So that's what So I said, "Yes, please." Now, so the talk I've decided to call David Hume, Joanna Lumley and the Abominable Snowman. The connection between the three, I hope, will become clear as I go through. But first of all, let me introduce myself. I'm a geneticist and bag inventor, and I've been interested in human evolution for a long time. And I think, I was just trying to think, from what point can I trace the reason that I'm here tonight? And it goes back, I think, to the late 1980s, when I was working in Oxford on the genetics of some bone diseases. I'm originally a medical geneticist, and a friend of mine who was in the archaeology department said, "Wouldn't it be fun if we could get DNA from archaeological bones?" So I said, "Yeah, wouldn't it?" And thinking, well, there's no chance of that happening. So we went down the road to, to a site where they were excavating a Civil War cemetery down the road in Abingdon, not far from Oxford, and to make way for a Waitrose supermarket. And you'd be glad to know that I've also got Waitrose interested in coming out with a new kind of bag as well. They're going to make it green, I believe, to distinguish it. Anyway, here's someone from the Civil War, and I remember looking down into his grave and thinking, well, there's no chance of any DNA being left in the bones of anything here, because I used to think, like all geneticists, that DNA sort of broke down almost immediately. You took it out of the freezer. But that wasn't the case, and after a couple of years we were able to get DNA from this and other specimens, and wrote that up in the journal Nature in 1989. Since when, all kinds of things have been coming to my lab, and I'll tell you about a couple of them, where people are asking, is there any DNA in this specimen? And I had the whole fridge was full of the most wonderful things. I had a bit of Mengele, the Nazi doctor, so-called. I had poets, a bit of St. Luke at one time. All sorts of things were coming through. A bit of the Iceman, to see whether there's any DNA remaining. And in some cases there was. And the DNA that I was looking at, in particular, was one that is found in all cells. It's called mitochondrial DNA, and it's a circle of DNA. It's a circle because it was originally came from bacteria. Now, it's very unusual inheritance pattern in mitochondrial DNA, and the reason is that it's found in eggs and not in sperm. Here you see a sperm about to fertilize an egg. So that means that all the mitochondria that we all have, and we all have it, has come from our mothers, not from our fathers at all. And this, for this reason, that there's the egg being fertilized, here's the fertilized egg. All the mitochondria, these little red dots, are in the egg, and they're in the fertilized egg here. This is the nucleus from the sperm and the nucleus from the egg that grows into an embryo and then into an adult. But only adult females produce eggs, of course, and that cycle continues. Adult males don't produce eggs. So the simple conclusion from that is that if you think about your own DNA, your mitochondrial DNA has come from your mother. Let's say this is you. It's come from your mother, not from your father. And from her mother, and 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 so on. So at every generation, there's only one woman alive that's given you her mitochondrial DNA. And this goes back hundreds, thousands, tens of thousands of years. And you can use this to connect two individuals together, because looking at their DNA sequence, I'll show you how, you can tell how closely related they are. So here's a relative of mine on the left, Tsar Nicholas II of Russia, the last Tsar, who was executed in 1917, and this is his cousin, George V. Now his DNA was got out of his bones, recovered, and it was used to prove that it was indeed the Tsar when his grave was, when the bones were taken from his grave in about 1991. And that was how they knew that it was the remains of the Tsar, because they used relatives of the Tsar, including the Duke of Edinburgh, funnily enough, and showed that if they were related maternally, they had the same mitochondrial DNA in the Tsar's bones and in his maternal relatives, of which it turns out I am one. Not because I knew that I was related to the Tsar, but because we have an almost identical mitochondrial DNA sequence. So here's, so I know that he and I are descended from a common ancestor way back in the past. He has one genetic difference. There's one genetic difference between him and me. And that means, since we know how quickly DNA changes over time, that means he is a common ancestor, as both of us lived about 10,000 years ago, or within the last 10,000 years. And I asked a solicitor friend of mine, I said, would that put me in any chance of getting any Romanov fortunes by showing a genetic connection, but apparently not. It's been tried, believe it or not. So what exactly are we looking at? Well, we're looking at the circle of DNA, and here's a diagram. Here it is in diagram, and we'll come back to it later. And if you sequence that, you get the sequence of the 4 DNA letters in a very small part of this mitochondria. It has lots of the differences between different individuals, and you just sequence through here, they can compare the two. And you'll find between different individuals there'll be changes, like this G changes to a C. So, but sometimes they don't change, like this A is the same. So with a large number of individuals, you can begin to connect them together through the maternal lines just by looking at the sequence of their mitochondrial DNA. So like this. So here's the Tsar Nicholas and myself up here, and we might be less closely related to a German, not all Germans, but just an individual German, than we are to each other. And then a Polynesian, who has even more mitochondrial changes between them than myself or the Tsar or the German, is because the common ancestor between that Polynesian and the 3 of us lived longer ago. The Bushman from Botswana, San, would have mitochondrial sequences even more different. Again, because we were related to this common ancestor who lived even longer ago. And you can push this back by looking at, for example, Neanderthals. About a dozen Neanderthals have had their sequences, remains of Neanderthals have had their sequences worked out, and sure enough, they're quite a lot different to any living human, and that's because they had common ancestors with all of us, but it was a very, very long time ago, at least 500 million years. Now, when you look at, say, Europeans, you'll see this is a complicated diagram you won't need to go into, but each of these circles is one or more individuals with a particular sequence, and they're all related to one another, and the connections are the lines between the circles. So, for example, these pale blue circles here, they're like this because all the people within this group are descended from the same common ancestor. And you can work out how long ago that common ancestor lived by looking at how many mutations have happened since that time, factoring in mutation rate. And you find that it's an individual living about 23,000 years ago is the common ancestor of all of these people living in Europe today. Now, the same goes to the other 7 groups that you find in Europe. In other parts of the world, there are other equivalent groups. It's just how it turns out. Now, to emphasize that these are not some theoretical construct, but they're individual women who managed to survive, managed to have children. I gave them names, and in a book I wrote, I worked out from, I imagined really, but from the archaeological evidence of where they lived and how long ago they lived, what their lives were like. And they really were the ancestors of a lot of the people in this room. Now, when this came out, and the book came out, there's quite a lot of interest from the media, and the only question that people wanted to know when the Daily Mail, for example, ran is what did they look like? Astonishing. So I said, well, I have no idea. And so I said, well, you work it out, you make it up, you think about it. So this is what the Reader's Digest is. And you'll recognise most of these ladies, and of course, there's no doubt that's absolutely correct. That's exactly what people living 30, 40, 50,000 years ago would have looked like. But where they got the makeup is another unanswered question about the past. Now, one of the things I became interested in after this was whether or not there were any people alive today who had ancestors that were not one of these seven daughters of Eve, as I call them, but were actually descended from Neanderthals. And just to remind you, Neanderthals have this very characteristic skull shape with high, prominent eyebrows, and prominent cheek, not much of a chin. And it's quite different from the skulls of anatomically modern humans, which are always thought to be our ancestors, which appeared in Europe something like 40,000 years ago. So the question always has been, still is in a way, is were the Neanderthals the progenitors? Did they evolve into having this skull shape? It's perfectly possible. Or were the Neanderthals, did they become extinct? And then Europe and all other parts of the world were then taken over by anatomically modern humans. So, to try and prove this, I and other labs looked at very old specimens of Homo sapiens and Neanderthals too. This is a colleague, Chris Stringer from the Natural History Museum. This is a 14,000-year-old, beautifully preserved jawbone from someone who lived in Cheddar Cave in Somerset. And we managed to get, by drilling into the teeth here using a modelling drill and a suction device, get out powdered dentine, which contained plenty of DNA. And using that and comparing it with the modern DNA from living Europeans, we could see quite easily that these old specimens, even as old as 14,000 years, were genetically very similar to modern people. And only when you looked at Neanderthals were they very, very different. And now, even though there has been some genetic data put forward that there might have been interbreeding between Neanderthals and ancient humans, and that up to 3% of our DNA may be Neanderthal in origin on average. The fact is that nobody has yet been found, and there's probably been at least 100,000 people tested who have Neanderthal mitochondrial DNA. And I was looking out for that, and that's how I first got to know Jonathan and Richard, because when they went to the Caucasus Mountains, I asked them if they would take some DNA swabs from people living in that region to see whether they carried any DNA from Neanderthal or Neanderthaloid human species that Richard was looking for, the Almasty, I guess. But as it stands at the moment, from the ancient DNA work and the mitochondrial DNA, there are no Neanderthals surviving in Europe. Nobody has. I haven't tested everybody, of course, but I haven't found any, nor has anyone else. So, what happened to them? Of course, and you can now see where this is going with respect to your own interests. And did they die out? Did they interbreed? Or are they still alive somewhere? So this is a rough diagram of the family of our genus, Homo, with ourselves, sapiens over here, and Neanderthals here. Another type of Neanderthal found and identified as a different species merely on one little piece of bone. That's found in the Altai Mountains in Siberia. Very different sequence from the other dozen or so Neanderthals that had their mitochondria recovered in sequence. And they seem to be more closely related to us than, say, for example, the little hobbit man, the Homo floresiensis from Indonesia, that was recently discovered, does seem to be a new species, or Homo erectus, the extinct hominid from mainland Asia and from Indonesia as well. Now, no DNA has been recovered from floresiensis. Not quite sure why, but they say there isn't any left. I'd be surprised because it was found in a large limestone cave, here it is, on the little island of Flores in Indonesia. And limestone is excellent at preserving DNA, but apparently none has been recovered. And this is what the skull looks like. Quite different from the skull of a Neanderthal. Here's another Neanderthal. So I was thinking, well, what about, can I find any other people that might look like Neanderthals, for example? Well, that's always, people are always saying, oh, if you're interested in Neanderthal DNA, I know who you should go and test. But it's never them, it's always someone who works around the corner or down the road. But I did find in Edinburgh, in the Museum of the College of Surgeons in Edinburgh, a very interesting skull called the Neanderthaloid skull, collected by a surgeon who was interested in deformations, genetic deformations of the skull. And he collected this skull here. This is a beautiful drawing of the skull. You see that these prominent eyebrows, other features are not so much like Neanderthals, but I still thought it was worth testing. So I did manage to persuade them to let me take a bit of DNA from the inside of the cranium, and I managed to get some DNA out of it. The first thing was, how old was this skull? Because if it was 40,000 years old or something like that, then it would just be a regular Neanderthal and not particularly interesting. But I did it, so I did a carbon date on this, and it's only 250 years old. And this individual, when he was alive, must have looked very much like a Neanderthal in many ways. However, his DNA, which was also managed to sequence because it's a well-preserved skull and relatively young, turned out not to be Neanderthal but to come from Africa. So anyway, that led me to wonder about the sorts of things that you're most interested in, and in that way led me to be here this evening. And of course, as you know, I don't have to tell you really, but just really to remind myself that the great interest in other hominid species, if they still exist, comes from the Himalayas mostly, and started the real public interest started, of course, with Shipton's expedition in the early 1950s, where he photographed this famous photograph of the footprint of the Yeti, or the abominable snowman. Now, as you know better than I do, many people have seen creatures, many of them reliable witnesses, some less reliable, but one of the reliable ones is Reinhold Messner, the alpinist. Here he is actually looking not at the Yeti, but looking at the Iceman, which he was found on the borders of Italy and Austria, and which I managed to get some DNA out of him. This is Messner here, but Messner has also seen creatures in the Himalayas. This is a more recent photograph, and has written a book about it, which I'm sure you've all read. And of course, this brings us into the popular appeal of Yetis and other hominid species. And one of the things that interests me is what's the basis of that appeal. And of course, there have been many sponsored expeditions. Some of them, of course, now are going on from your centre. Others have been almost farcical. For example, there was an expedition that was supposed to be launched by this man, the famous Shakespeare actor Bryan, and when it was written about, it was said that the only large hairy monster that they came across was in fact the expedition leader himself. But of course you don't need to do much reading around the subject before you come across the founder of cryptozoology, Bernard Heuvelmans, and this is an early shot of him. And with a Yeti behind him, the Yeti in this case being, this was a painting by his wife, who was a very talented painter. He had, as I'm sure you know, a very interesting life. And the Yeti here, you can see you can't actually, but you'll see in the next shot, that part of the reason for that strange head is this item here, which he and others have studied, which is the scalp of a Yeti, supposedly. I think this is the one that was brought back to, not discovered, but given to Edmund Hillary on one of his expeditions. Now, Heuvelmans, a very interesting man, and like all of you, I'm sure, I've read his book In the Search of Unknown Animals. And what comes across in that book is that he was a serious scientist trying to prove, he had a PhD in biology, zoologist, trying to prove what he believed to be true, in that there were, as many of you do, believe that there are animals unknown to science. But how do you go about proving that? And there's no doubt that reading through Heuvelmans' work and other cryptozoology treatises, there's the feeling that, and as Heuvelmans himself felt, he was rejected by the scientific establishment, that the scientific establishment was not prepared to accept what he believed. And so, from my reading this work and other papers, I get the feeling that he felt that he was being unfairly rejected by the scientific establishment, that they would never believe what he said. Now, this is not what my view of science is. Science is not something that is an establishment or can judge something or reject somebody else. People can do that, but science itself is a branch of philosophy, and it's basically disinterested in opinions and only comes to conclusions based on evidence. So what evidence would be sufficient to convince anybody that, for example, a hominid found in the Himalayas was either up to hereto thought to be extinct ape, or a type of hominid, or a Neanderthal, things like that? Well, of course there's an abundance of circumstantial evidence, and some of it you see in the footprints, the very convincing, I'm easily convinced, of eyewitness accounts, photographs, these kinds of things. And in the case of Heuvelmans, he, as I'm sure you know, he studied intensely this Minnesota Iceman, a hominid, question mark hominid frozen in the block of ice. But he never managed to get a sample from it, and it disappeared before he could. A familiar tale in cryptozoology exploration. So he studied it and made drawings. And here he is in later life. He kept a most wonderful archive, kept in these rock slides, which you see behind him. And I was interested in, how was he trying to prove that what he believed to be true was true? And that's why David Hume appears in the title of this talk. David Hume was a philosopher. He wrote a very famous essay setting out what it would take to convince him that a miracle had happened. And so interpreting that into the world of cryptozoology. Because the claims that are made are extraordinary, then the proof must be extraordinary and must satisfy Hume's conditions, in that case for belief in miracles, which basically are that it's more likely to be a miracle than not to be a miracle. But it has to be based on evidence. And I was very interested in this aspect of it, because I don't agree with the idea that science rejects cryptozoology and cryptozoologists. Science doesn't do that. Science just looks at the evidence. So I went to Lausanne, where Heuvelmann's archive is kept, very well curated there. And reading through that, I didn't spend long there, but reading through that, it was obvious that Heuvelmann was trying very hard to prove these things, and he was very disappointed, particularly by his efforts with the Minnesota Iceman, when reputable institutions like the Smithsonian originally thought it was worth investigating, then sort of backed off as it became more mysterious. So that's how David Hume comes into this, and I'm strongly of the opinion that cryptozoology and cryptozoologists need not fear science, but need to come up with evidence, and we'll come on to what that might be. So, the next character in the title is Joanna Lumley. Now here she is in in two of her characters, the seductive Purdy in the Avengers, and any of you who were alive in the 70s will remember that, and of course is in Absolutely Fabulous here. But she's also known as the saviour of the Gurkhas. Here she is, and almost a goddess for her work in this area. And the reason that she's involved with the Gurkhas is because her father, I think, could be her grandfather, I'm sorry, I'm not sure. Pictured here was one of the first, I would imagine it was grandfather, one of the first Europeans to make a visit to the Himalayan kingdom of Bhutan, and led a diplomatic mission to meet the king there. Bhutan is a beautiful place. I haven't been there, but it's a small mountainous kingdom, and it has a very strong legend of a Yeti, or Yeti type, the Migoi, so strong that it features on the stamps of Bhutan. And in monasteries in Bhutan there are organic remains. And here's one from which there was a pelt kept for the health of monks. Those that slept on the pelt of the Migoi were alleged to be cured of their complaints. So here is actually some organic remains that can be tested, and I think cannot be falsified. And unlike other forms of evidence, photographic eyewitness accounts, even though the people that take the photographs or see things in the mountains, that is not good enough to satisfy Hume's principles of what it takes to believe the evidence. But if a pelt was found, or even a single hair that had, let's say, for the sake of argument, a Neanderthal sequence, that can't be falsified. So I was very interested, first of all because it gave me the chance of meeting Joanna Lumley for the first time, first and only time, because she was involved in making a film about Bhutan because of her connections there. And through that film, one that followed after that, I was approach to say, well, would I be interested in analysing this pelt, which I spoke, and other material that was collected from organic remains of the Migoi? So, of course I was. And what were these remains? Well, the first was a hair collected from a scratching post. The Migoi, according to the Bhutanese, traditionally will scratch at trees or posts, and hair from those posts can be collected. So one was collected, sample A, from a scratching post very high up, 3,500 metres. And then the pelt from the monastery, hair was given from the pelt from Thimphu, the capital, kept there, and collected by Harry Marshall in 1999. Harry Marshall is a film producer. He runs Icon Films, and they're the film company that approached me and also made the film. And with a bit of luck, we'll see some clips from that film. There's other things, the hair and droppings, a single hair and a root that was obtained from a tree den in a bamboo forest very high up. Other hairs from the same tree, and then another hair which didn't look the same that's from the same forest. And then dung, which, believe it or not, you can recover DNA from dung. It's very difficult. That was contributed by a Bhutanese, somebody very closely connected with the Bhutanese royal family, who have a very great interest in the Migoi and kept in the World. He was from the World Wildlife Fund, working there in Washington. So we were given all these samples to try and analyse using the mitochondrial DNA. This is the circle again. Now, if you're trying to look at the genetic differences between individuals in the same species, like the people in this room, then you use this particular piece of DNA here, because it has a lot of differences between individuals. We would needn't go into why that is. If you're looking for species differences, say between trying to identify a species, then it's best not to use that, and use this piece here, the cytochrome B gene, and that's what we chose to use when we were analysing these material from Bhutan. Now, the reason it's very difficult to do, because it's almost always going to be contaminated with human DNA. So let me show you how this is important, how you can get the DNA you want from a mixture. And it's done, this is a piece of DNA, a long strand. And let's say you're interested in this piece of DNA, between that point and that point. Well, what you do is to make, artificially, DNA that you sequence matches the different points at either end of the piece you want to amplify out. And that's what we do all the time when we're looking at any part of mitochondrial DNA in anybody, living or deceased, fossil remains. And it works by, you've chosen, here is the original DNA. You choose and make artificially little pieces of DNA, about 20 DNA units long, which will match exactly the regions of the DNA that you want to examine. And then using an enzyme called DNA polymerase, you artificially make another copy of the region in between. Here it is. And then you can repeat this, so that the first time you do it, and you can use automatic machines to do this for you, you heat it up, put the enzyme in, and the enzyme works at a certain temperature. Then the second time you do it 2, then 4. And you can imagine that then, as you do it, say 20 times, you have 1 million copies of that original piece of DNA. Absolutely fantastic tool that's been around for 20 odd years, called polymerase chain reaction. A chain reaction because, like a nuclear chain reaction, it builds up until you've got millions of copies of this DNA, enough to sequence. And it's only because of the specificity, the exact matching between these artificial pieces of DNA and the DNA that you're looking at that makes it work. I mean, it does work. So if you have a sample from, let's say, this pelt, then that was kept in the monastery and slept on, it's going to, of course, it's hundreds of years old, it's going to be covered in human DNA of one sort or another, maybe dog, goat, all kinds of things. What do you do about that? Well, if you just choose primers that will amplify any old mitochondria, then you're going to get, most likely, you're not going to get the DNA from the hair itself, but from the contaminating creatures that have touched it or slept on it. So you have to be very careful about the primers that you use. Now, I've read reports, and again, there are always popular reports of hairs being recovered from interesting specimens. And you always read, the Daily Mail is very good at this, you read that it's been found and that it's gone off to a lab, but you never hear what actually happens. And then you hear, oh, well, actually, I found human DNA. Well, of course you find human DNA on anything. So when when the hairs arrived from Bhutan, we did reactions using different primers. And if we used reactions that would primers that would identify human DNA, sure enough, we got human DNA out of it. But, so then we thought, well, what is it likely that these hairs or pelts come from? What are the other species? So we made primers that would, for example, amplify Neanderthal DNA, but they didn't amplify any DNA. And you just have to use different sets of primers, because what you're looking at is not only DNA from the original skin, but as I said, all these other contaminating DNAs which are bound to be there. Now, it's a very big problem, but it's not insuperable. And in the case of the samples from Bhutan, Helen Chandler, who was a student who worked on this, made primers that were for all different sorts of species. And the ones that she concentrated on were bear primers, because there was a chance that what this was were bears. And here is a diagram rather like the human diagram of 7 Gordon Eve, connecting different sorts of bear species, living species that we know about. This work was done 10 years ago, and it's been published in her thesis, but nowhere else. So now, if you did this now, you'd find there are far more of these sequences available, you'd be more precise. But the pattern that you get separates an Asiatic black bear, 2 individuals here, modern individuals. They're not the Megoites. Here's some individuals, modern individuals, bears from the Ursus archos, the brown bear, and here an ancient specimen from the cave bear. Now, after a lot of trouble, Helen managed to get good sequences from 2 or possibly 3 of those samples, as I explained. And one of them was when she then matched those sequences with these bears, using bear primers. Megoid A, which was the hair found at 3,500 metres at the scratching post, did not exactly match any of the bear species that had been published, but it was clearly in the same group as the Asiatic black bear. On the other hand, the pelt from the monastery, which was tested as well, was a different type of bear. It wasn't a black bear, it was an Asiatic brown bear. Brown bears are very variable in different parts of the world. They're all basically the same species. So this evidence, this is, I would think, good enough evidence to prove, well it is good evidence, to prove that those hairs and the pelt, though they're not from Migoids, they are identifiable as different species of black and brown bear. Now I'm going to try and see if these 3 clips that I've got, which contain embarrassing footage of me 10 years ago, will work, because there's one other hair that when you see the footage, I suppose I've had more email inquiries about the result of the other hair than anything else. But here we go. This will show you, it's quite interesting because it's if it works, show you what.
Humans share 98% of the same genetic makeup. All over the world, witnesses tell tantalizing tales of a creature half man, half monkey. In North America, it's known as Sasquatch or Bigfoot. In Asia, it's called the Yeti or wild man. But despite all efforts, no proof of this ape-like creature exists. For the first time, an expedition is setting off to the remote kingdom of Bhutan in search of the creature which the locals call the Migyur, the abominable snowman. The expedition's mission is to find evidence that will stand up to scientific analysis. Unlike Westerners, the Bhutanese firmly believe in the existence of the Yeti. No expedition has returned with hard evidence. Until now. Mission accomplished.
So that's from the intro.
The solution to this Himalayan mystery may lie in England, at Oxford University. Here, the vital 5th member of the team is a world pioneer in the identification of DNA. Professor Bryan Sykes was the first geneticist to extract DNA from archaeological bones. He will analyze any material that the team brings back.
DNA would be able to tell us. We'll be able to get the sample from the Yeti, whether it was human, whether it was a primate, whether it was a new species possibly, or whether it was a bear or something else like that. Absolutely the ideal tool, and it's never been done before, so I leapt at the opportunity.
This opportunity came with a mysterious skin said to belong to the abominable snowman. Professor Sykes sequenced the DNA of its hair. He was able to pin down its true origin.
If we're talking about that skin, then it's a kind of bear. Nonetheless, the sequence from that skin has never been seen before. That's not to say I couldn't tell from the sequence whether it's a particularly big or tall or fierce brown bear, but it wasn't the usual kind of brown bear. It may even be a special substance.
And the final hair.
Hey, we've got a hair with a follicle. Nice. Long black hair. This is great, Ted, because we're here at the tree which everyone says is the most positive place where the Migyur has been traced. And now we have a hair from that tree. We couldn't find the dung which we were hoping to find, that's gone, but we've got a hair, and that hair which should contain DNA. So that will settle once and for all what has been living in this tree. Brilliant.
Mission accomplished. The expedition hands over their precious samples to Professor Sykes for analysis.
What I got from you was hair, but the good news is that it had roots, had hair follicles on, and that's where all the DNA is. Now, because we were sort of half expecting a bear, because of the analysis of the skin sample, we went directly and asked the reaction to look specifically for bear DNA. But there wasn't any there. It's certainly mysterious. It's certainly mysterious. There was a nice plump follicle there. We normally wouldn't have any difficulty at all. It had all the hallmarks of good material. And some of the other hair brought back from the same region, we had no difficulty in proving what it was.
The hair sample has been tested against human, bear, and primate DNA. But so far, Professor Sykes can't match it with any known species.
We have found some DNA in it, but we don't know what it is. It's behaving most peculiarly. It's not a human, it's not a bear, nor anything else that we've so far been able to identify. A mystery. And I didn't think this would end in a mystery. We've never encountered any DNA that we couldn't recognize before. But then we weren't looking for the Yeti.
Now, we can put the lights up. I had more inquiries about that statement at the end of that film than anything else, as you can imagine. Now, the truth of the matter is that we filmed 3 endings for the film, because the problem with making documentary films is you have a tight deadline. So there was one in which we found a positive result, and then a negative result, and then the ambiguous result. And we didn't get a result from that. We did get DNA, it wasn't recognisable. But what that doesn't mean that it was an unknown species. What happens with DNA, if you have a sample and there isn't much DNA in it, then you'll get all kinds of nonsense sequences. So when that clip was made at the end of the filming, before it was broadcast, we hadn't identified what those sequences meant, and we never did. But I don't think that, although you might think that a rather appalling piece of acting, but what it was, a rather strange and undiscovered species. In fact, I think it was just one of those jumbled sequences that you get with samples where there's very, very little DNA at all. So, not by any means something that would satisfy the principles laid down by David Hume. So the summary of these Migoi samples from Bhutan, one was definitely a black hair, one definitely a brown hair, and no DNA from either the other hairs from the same tree or from droppings, very difficult with droppings. We did find the other hair that nobody really thought was a Migoi, was actually a sus scrofa, which is a wild boar. But nonetheless, it was able to produce unambiguous evidence. So, what's happened since then? I've been doing lots of other things, but I've always been curious about how far DNA analysis of this sort, if it's properly done, can be used to identify positively material which you and others find on your expeditions, and which are in museums and collections throughout the world. So what I've done is we're starting as a systematic survey, which I invite those of you who are interested, who know of or have samples of your own, to be examined. I'm collaborating now with the Museum of Zoology in Lausanne, where the Prof collection is curated, to try and see whether there really is a good collection, not just one hair, but a good collection of material, not just from these collateral human species, or Migois or Yetis, but any other cases where identification is possible. And now, because of all the species that have been sequenced, and with the much more recent ways of analysing this, which you can do without having hair roots at all, you can now do this on hair shafts, then I'm sure that anything that was produced, that was say a Neanderthal or an ape of unknown, that was nothing like any known ape species or any other cryptozoological specimen, would not be rejected if these things are done properly, and that includes repeats, so it's always best to have more than one hair. They would be accepted as evidence by the scientific establishment, and I'm eager over the next few years to find examples of that, because I do believe that the scientific method and the scientific approach is the one that will, in the end, come to proper conclusions about the sorts of activities of which you're all enjoying and engaged. And I'm sure, had he been alive, that Bernard Heuvelmans would have been the first to try and use these modern DNA tools to identify the specimens which came his way. So, we're putting together with Michel Sartori from Lausanne a research program which we'll announce fairly soon, and I hope you'll all keep an eye open for that and consider whether to contribute to it by sending us some of your material. So I've got to thank Helen Chandler, who did the legal work, a research student by Oxford, Harry Marshall from Icon Films, and Lady Antonia Fraser for reasons that didn't come into that I missed out at all. But through her, we found an even better way of getting hair samples analysed on individuals quite a long time ago. I've mentioned Michel Sartori, and this is my contact details for any of you who feel that you have something that you would like to put through this proper genetic scrutiny. And with that, thank you, Jonathan. Thank you all very much.